Alright, let's talk about what actually makes Python so powerful. Yeah, the syntax is clean. Yeah, it's readable. But honestly, the real superpower is the ecosystem. We're talking over 450,000 packages on PyPI alone. That's decades of collective engineering effort, just sitting there, ready to pip install. This guide is your map through all of it. Alright, let's talk about what actually makes Python so powerful. Yeah, the syntax is clean. Yeah, it's readable. But honestly, the real superpower is the ecosystem. We're talking over 450,000 packages on PyPI alone. That's decades of collective engineering effort, just sitting there, ready to pip install. This guide is your map through all of it. First up, the core system and runtime modules. These are the ones that talk directly to the interpreter and the OS. You've got sys. That's your window into the Python runtime itself. Things like sys.argv for grabbing command line args, or sys.path for messing with where Python looks for modules. Then there's OS, your go-to for anything OS level, creating directories, reading environment variables, all that. Now, if you're still using os.path for file paths, do yourself a favor and switch to pathlib. It's object-oriented, way cleaner, and honestly just feels more Pythonic. And finally, built-ins. You never import it, but it's always there. That's where print, len, int, all those live. It's the namespace that's always loaded. Next, data types and collections. Python's built-in list and diked are great, but sometimes you need something more specialized. The collections module is where it's at. You've got named tuple for lightweight, immutable records. Think of it like a struct with named fields. There's dequay, which is a double-ended queue, way more efficient than a list when you're appending and popping from both ends. And counter, which is just brilliant for frequency counting. Then datetime. If you're doing anything with timestamps, time zones, or date formatting, this is your module. Don't try to roll your own date logic, please. Enum is great for representing fixed sets of options, like statuses or modes, in a clean, safe way. And copy handles shallow versus deep copying of objects. Super important when you're working with nested data structures and you don't want mutations bleeding through. Alright, math time. The math module gives you your constants, p, e, plus trig functions, logarithms, the works. For anything involving randomness, random has you covered. Random sampling, shuffling, generating numbers from different distributions. The statistics module is handy for quick descriptive stats, mean, median, variance, standard deviation, without pulling in NumPy. And then there's decimal. This one's critical if you're doing anything financial. Floating point arithmetic in Python, like in most languages, can give you those weird rounding errors. Decimal gives you correctly rounded, arbitrary precision arithmetic. If money is involved, use decimal. Full stop. Now let's talk about getting data in and out of your programs. JSON is basically everywhere. Anytime you're talking to an API or a web service, you're dealing with JSON. Python's JSON module makes encoding and decoding it trivial. CSV is the universal format for tabular data exchange. Spreadsheets, exports, you name it. SQLi TE3 is a gem. It's a full relational database, right there in the stdlib, no server needed. Perfect for local storage or prototyping. And Pickle. This one's for serializing Python objects. You can take any Python object, pickle it to a byte stream, save it to disk, and reload it later. Just be careful loading pickles from untrusted sources. It can execute arbitrary code. For networking, the stdlib has some solid low-level tools. URLlib is the built-in way to fetch data from URLs and parse web addresses. It works, but fair warning. Most devs reach for the third-party requests library instead, because it's just so much more ergonomic. HTTP gives you HTTP status codes and a basic server. Useful when you need to understand what a 404 or a 503 actually means in your response handling. Socket is the low-level BSD socket interface. You're talking raw TCP and UDP here. And email handles the full lifecycle of email messages. Passing headers, dealing with MIME types, attachments, all of it. Okay, concurrency. This is where a lot of devs get tripped up. So let's be clear about when to use what. Threading is for I/O-bound tasks, like waiting on network requests or file reads. Multiple threads, single process. But here's the thing. Python has the GIL, the Global Interpreter Lock, which means threads can't truly run Python bytecode in parallel. So for CPU-bound work, you need multiprocessing. That spawns separate processes, each with their own interpreter, so you get true parallelism across CPU cores. And then there's Asyncio, the modern approach. It's single-threaded but uses async/await syntax to handle tons of concurrent I/O operations without the overhead of threads. If you're building anything high throughput, like a web server or a network client, Asyncio is where you want to be in 2026. Alright, now we're stepping outside the SteadyBee and into the wider ecosystem. PyPI has nearly 500,000 packages, but let's be real. A relatively small group of third-party libraries dominates the landscape. We're talking about the ones that have become so foundational, they almost feel like part of the language. We've grouped them into 4 buckets: data science, AI and machine learning, web and APIs, and automation and DevOps. Let's go through each one. Data science is honestly where Python made its name. NumPy is the bedrock. It gives you the n-dimensional array, the end array, and all the high-performance linear algebra tools that everything else is built on. Pandas introduced the data frame. Think of it as a programmable spreadsheet. It's the industry standard for cleaning, transforming, and analyzing tabular data. Now, Polars is the new kid on the block, and it's fast. Like, seriously fast. It's written in Rust, uses Apache Arrow under the hood, and handles massive datasets where Pandas starts to choke on memory. If you're working with big data, keep an eye on Polars. And SciPy sits on top of NumPy for more advanced scientific computing, optimization, integration, signal processing, that kind of thing. Python is the undisputed home of AI, and these 4 libraries are why. Scikit-learn, or sklearn as everyone calls it, is your go-to for classical machine learning. Regression, classification, clustering, decision trees. It's got a clean, consistent API, and it's the best place to start. PyTorch is currently the dominant framework for deep learning. Researchers love it for its flexibility and its Pythonic feel. You're writing real Python, not a static computation graph. TensorFlow and Keras is Google's ecosystem. It's massive in production and enterprise settings, especially for deploying large-scale neural networks. And Hugging Face? Think of it as the App Store for AI models. It's the primary way most devs access pre-trained LLMs like Llama, BERT, or GPT-style models. If you're doing anything with transformers, you're probably on Hugging Face. Python powers a huge chunk of the web's backend, and these 4 libraries cover basically every use case. Requests is the gold standard for making HTTP calls. It's so much cleaner than URLlib that it's become the de facto replacement. Django is the batteries included framework. It's got an ORM, an admin panel, a youth, the works. Instagram and Pinterest run on Django. FastAPI is the fastest growing framework right now, and for good reason. It uses Python type hints to auto-generate API docs and gives you async performance out of the box. If you're building a new API in 2026, FastAPI is probably your answer. And Flask is the micro framework. Minimal, flexible, great for small projects and microservices where you don't need all of Django's machinery. Last category, the behind-the-scenes stuff. Boto 3 is the official AWS SDK for Python. It's consistently one of the most downloaded packages on all of PyPI, which tells you how much Python is used in cloud infrastructure. Pydantic is essential for data validation. It uses type hints to make sure the data flowing through your app is in the right shape. If you're building APIs, Pydantic is basically non-negotiable. Selenium and Playwright are your browser automation tools, simulating real user interactions, web scraping, end-to-end testing. And PyYAML is everywhere in DevOps, reading and writing YAML config files, CI/CD pipelines, Kubernetes manifests, you name it. So let's wrap up with the big picture. If you had to pick the 3 most important third-party libraries in Python right now, it'd be Pandas for data, PyTorch for AI, and FastAPI for web. Pandas is the standard for data manipulation. cleaning, transforming, analyzing tabular data at scale. PyTorch is where the deep learning world has converged, research and production alike. And FastAPI is the modern standard for building fast, self-documenting APIs. Around each of these, there's a supporting cast. NumPy, Polars, and SciPy round out the data ecosystem. Scikit-learn, TensorFlow, and Hugging Face fill out the AI space. And Requests, Django, and Flask cover the rest of the web. That's your Python ecosystem in a nutshell.